Hey guys, so we are going to start the skeletal system today. Okay, we've talked a little bit about parts of this before when we did the parts of the compact bone, so some of this will be a review, but much of it is going to be brand new. So somewhere in your notes, you need to make sure that you have this. I know it's not in the actual notes packet, but it's going to be important for later on in this chapter. So basically, your skeleton can be divided up into two separate skeletal systems. You have what's called the axial skeleton, okay, which is the skull, your vertebrae, so essentially like the cervical, thoracic, and lumbar vertebrae, all of those, and the sacrum, and your rib cage. So think of it as the long axis of the body going from your head down to about your hip area. Okay, it does not include any arms or legs. Any structures associated with the arms and the legs are considered your appendicular skeleton. So you can think appendicular appendage. So basically that means that we're talking about the bones of the arms, the bones of the legs, and then the bones that hold those structures to the arms and the arms and the legs to the body. So in the arms, we'd also be talking about the clavicle and the scapula make up the appendicular. And for the legs, it would be your os coxa, okay, your hip bone would be included here in the appendicular skeleton. So here are your 5 functions of bones. Obviously, supports the body. Protection is a big one, especially when we start to talk about flat bones like your ribs and your skull. Okay, flat bones are designed to protect vital organs, even the spinal cord in the case of your irregular bones of your vertebrae. Movement, it provides a place for your muscles to attach so they can move your arms, move your legs, move whatever. It stores minerals, okay, especially calcium. So calcium is not only important for strong bones, but calcium is really important for your nerve cells to do their job. So whenever our body needs calcium, it will steal it from the bones. That's why it's important to have a good reserve of calcium in your bones. And also blood cell formation. Blood cell formation is basically the making of your red blood cells, your white blood cells, and your platelets. And that happens in the spongy bone, in the bone marrow. And the process by which we make new blood cells is this word here, hematopoiesis. So every time you see hema or heme or something hemato, that means blood. And then whenever you say this poiesis part, that means that we're creating whatever it is. Okay, so if we specifically said erythropoiesis, that would be the making of red blood cells. Leukopoiesis would be the making of white blood cells. Okay, so hemo or heme or hemato, that always means blood. All right, so study of bones is called osteology. We've got lots of O words here coming up. So we know that bone tissue is predominantly obviously found in bones, but you're also going to find a little bit of it in each one of these other connective tissues and nervous tissues. Okay, so because your blood cells are made in the bone, they're going to pick up a little bit of bone tissue, okay? Your marrow is embedded in the bone, so it's going to have some bone tissue. Cartilage is attached to bone. Adipose tissue is also found in bone, okay? So anything fibrous connective tissue is going to be your dense connective tissue for your tendons and like your ligaments attached to bone. Okay, nerves run through bone. So anytime you have something associated with bone, it might pick up a little bit of osseous tissue. All right, so that's basically where we're starting right now. So there are 5 classifications of bones. Okay, so first one we have is our long bones. These are going to be the bones that predominantly make up your arms and your legs. These are bones that are longer than they are wide. So even like the bones that make up your fingers and your hand, so your carpals, your metacarpals, not your carpals. Your metacarpals are going to be long bones. Your phalanges are going to be long bones. Your metatarsals, the bones in your foot, are going to be long bones. Any bone that is longer than it is wide are going to be considered long bones. If you have long bones, you also need to have short bones. And these are going to be bones that are relatively equal in length, from length to width. Okay, so these are going to be like your carpals and your tarsals, the bones that make up your wrists and your ankles. They are going to be considered short bones. Then we have what we call flat bones. I mentioned them in the very beginning. Flat bones are usually protective bones. These are bones that are going to be not super thin, but fairly thin and usually pretty wide. Okay, so these are going to be bones of the skull, bones of the rib cage, your sternum. Think about bones that actually protect other structures. Okay, even your hip bones are going to be flat bones. Then you have what's called irregular bones. Okay, irregular bones are bones that have no normal shape to them whatsoever. So basically, we're talking about here is your vertebrae. It's all the bones that make up your thoracic vertebrae, your cervical vertebrae, your lumbar vertebrae, your sacrum, okay, your coccyx. Those are all examples of irregular bones. So these are the four that appear in your notes. There is a fifth type of bone, which is pretty rare. Okay, everybody has at least two, really, and that's going to be what's called a sesamoid bone. A sesamoid bone is a bone that actually doesn't articulate or touch another bone because it's embedded in tendons, and the example in the human is the patella. Okay, so when we get into class, I'll actually show you the way that the patella is actually buried in the patellar tendon and the patellar ligament that goes straight across the top of the knee joint. Okay, so here are all your examples. You can see your long bone, they're giving you the humerus there. Flat bone, they're showing you the sternum. Your irregular, which is your vertebrae. Your sesamoid was the patella. And then a short bone, they're showing you the trapezoid of the wrist, one of your wrist bones. Okay, here's some other examples. So bone anatomy. So we're specifically going to talk about long bones when we do bone anatomy. So we're basically going to, in activity number 1, you guys are going to look at the structure of a long bone. Specifically, you're going to look at the humerus, which is the picture on the left here. And you're going to be able to identify all of the different structures to it. So every long bone has two major parts to it. It has the shaft of the long bone, which is called the diaphysis. And then it has the ends of the long bone, which are called the epiphyses, okay, or the epiphysis. And you always have two epiphyses. You'll have a proximal epiphysis, which is going to be closer to your shoulder or closer to your hip. And then you'll have the distal epiphysis, which will be the one that's further away from the shoulder or the hip. And if you look at them, you can see that they're a little bit different. So if we look at the epiphyses here on the ends, even this end will have it too, it's just not pulled away. But you can see on the outside, we have a layer of compact bone, but the ends of your long bone, you can see, are filled with spongy bone. Okay, so this is basically where a lot of our blood cells are going to be made, are found here in the ends of our long bone. You can also see in this proximal epiphysis, you'll also have it in the distal one too. You can see this faint line here. We call that the epiphyseal plate, which is basically your growth plate. So that's going to be a layer of hyaline cartilage there that allows your bone to continue to grow. Eventually, this will disappear and it will become all spongy bone in this area. Okay, the diaphysis, which is the shaft of your long bone, you can see you have this thick layer of compact bone down here, but then you have this hollowed out tube, which is called the medullary cavity, which is where we actually find, so this is red bone marrow here in the spongy bone. This is actually called yellow bone marrow here in this medullary cavity. Okay, covering all of our bones, we have a membrane called the periosteum. Okay, it's a double layer membrane. You can see it here. It's been pulled back here, and you can see all these little fibers that are holding it together. So these little fibers are your Sharpie's fibers. So if you think about the last time you had like maybe a steak that had a bone, or if you had chicken wings and were on the bone, and you start to pull the meat away, the meat is actually the muscle. Okay, and you actually, if you get close enough, you are actually going to pull the periosteum off of the bone as well, and that's when you start to see these little Sharpie's fibers. They're what holds that membrane onto the bone and protects it and nourishes it, because you can see we have all these arteries running across the periosteum, so it helps to nourish it from the outside as well. We're also going to have bone building cells involved in here called osteoblasts. You can always remember blast build bone, osteoblast build bone. Okay. And you can see that your periosteum is also made up of dense, irregular connective tissue there. So it's going to be nice and strong. So the periosteum is on the outside here. The endosteum is the lining inside of that medullary cavity in our diaphysis here. And you can see it up towards the top. The endosteum is very delicate. It's very thin. It lines that medullary cavity. Just internal to that is going to be your yellow bone marrow, which is basically where your bone stores fat. It actually helps your bone stay slightly flexible, not super brittle. Okay. Flat bones, short bones, and irregular bones do not have this medullary cavity. They'll have compact bone. They'll have a little bit of spongy bone as well. Okay, but they do not have this medullary cavity that contains that yellow bone marrow. So a couple more vocabulary terms that you don't want to get confused with each other. We will be using these over and over again, especially the suffixes for each one, depending on what we're talking about. So we might talk about a blast, a site, or a class, so you need to know what those mean. Okay, osteogenic cells are going to be bone cells that are found in the endosteum. So going to be found in that medullary cavity. And they're basically going to be the cells that produce two of these other cells. They're going to produce osteoblasts and osteocytes. Okay, osteoblasts are bone forming cells. So I always think blasts build bone. Okay, so osteoblasts build bone. They're going to make new bone. So when you, every year you replace a certain percentage of bone. As you grow, you have to add more bone. If you break a bone, you have to be able to rebuild it. Osteoblasts are responsible for all of that. The osteocyte is the mature bone cell, okay? It's really helpful in bone maintenance, making sure that your bones are strong and they're not brittle. We saw those in the lacunae in the osteon. When we talked about that, we're going to talk about it again in a minute. Okay, and then you have osteoclasts. And osteoclasts actually break down bone. And you're probably thinking, why would I ever want to break down bone? Well, if there's a bone cell that's not doing its job, or it's injured, or it's broken, or like you get a bone break, some of those cells in that area are no longer functional. We don't want them just hanging around. So the osteoclast will actually break those down, and it will allow your body to reabsorb the different parts of that matrix, the calcium phosphates, and things like that, so that you can use it to build brand new bone. Okay, so blasts build, clasts break down. We occasionally mention this. It's just part of your matrix. So in the bone, instead of just calling it mineral salts, we call it hydroxyapatites, okay, which is basically what makes up for more than half of your mass of your bone. It's mainly your calcium phosphates. It has some collagenous fibers in it. It's essentially responsible for the hardness of your bone and the resistance of your bone to collapsing or compression or being really, really brittle. So it's just a really important part of the matrix of the bone. So here's everything that's in that matrix. You can see we mentioned that hydroxyapatites there. There's your other mineral salts: magnesium, sodium, potassium, bicarbonate. Okay, calcium phosphates. Calcium phosphates are important for blood clotting. I mentioned the fact that calcium is stored in your blood. That's important for nerves to do their jobs. You're going to see when we talk about muscles and we talk about the steps involved in a muscle contraction, we need those calcium phosphates for that as well. And you're going to have a certain amount of water in the matrix of the bone. And by the matrix of the bone, we're talking about all that space between those osteocytes. We'll get to that in just a minute. The organic stuff that makes up your bone is going to be cells, so it's going to be osteoblasts, osteoclasts, osteocytes, all of those. Fibers like collagen. Okay, and the collagen is important for bones because it makes the bones a lot less brittle. Remember, I told you guys before the eggshells were also made up of calcium and calcium phosphates, but they don't have collagen. So that's why an eggshell is so brittle, but our bones are not. Okay, so one of the things that I mentioned before is that bones can absorb harmful, well, you can read, I didn't mention it. They can absorb harmful things, harmful metals like lead and radium and strontium. And what ends up happening there is that once your bone gets it and holds on to it, it doesn't let go of it. So that's why lead poisoning is such a big thing. Okay, because in lead poisoning, essentially what's going to happen is that your bones are going to absorb the lead and they're going to hold on to it. So every time a bone cell makes more bone cells, like your osteoblasts make more bone cells, all of those new cells are going to have lead in it. So what might have started off as a small amount of lead is going to quickly become a large amount of lead. Okay, we actually can break down bone by taking the bone and sticking it into some kind of acid. Okay, like even vinegar. So if you were to do a little experiment, if you were to have wings one night, let's say you had chicken wings, and you clean all the meat and stuff off the bone, and you're just left with the bone, and you were to stick that bone into a glass of vinegar, and you were to come back in a couple of hours, you'd be able to bend that bone. It becomes so flexible. Okay, if you were to take that same bone, well, before you did this to it, and you were to put it in the oven, you were to bake it, basically baking it, what that's going to do is that's going to get rid of the collagen and they become brittle. So by dissolving it in vinegar, which is a weak acid, you're actually going to get rid of some of the calcium, and that's why it becomes more flexible. And if you stick it into the oven and bake it, you're going to get rid of the collagen, and that will actually cause it to become more brittle. So let's talk about the difference between compact and spongy bone. So compact bone is the external layer that's used for protection. Okay, it's compact, it's hard, it's tough, it protects. Spongy bone is going to be the vascular inside. It's going to have all those little nooks and crannies where we can find all of that red bone marrow. So these are the parts that we've already talked about. There's only one new part that we need to talk about, which is this Volkmann canal. So if you look at the picture, we have an osteon right here. You can see, actually, we have one that's cut open right here that you can really see. So that is an osteon. The very, very center is that Haversian canal. That's where the blood vessels and the nerves are found right down the center there. Okay, you can see the lamellae, the concentric circles going around. You can see the osteocytes on those lamellae. They're found in the lacuna. Okay, but our new structure is going to be this one that's going side to side here down the bottom, and that's called a Volkmann canal. So essentially what we have is down the middle of each of these Haversian canals is we have our blood vessels and we have our nerves, but nothing is really connecting one osteon to the next osteon to the next osteon to the next osteon. That's where these Volkmann canals come in, is that they actually will connect all of those osteons together and connect them to the periosteum on the outside of the bone. You can really see it in this picture. See the Volkmann's canal? It's also called a perforating canal. They're the ones that are all going horizontally here on the side. And you can see it starts over here at the periosteum and it goes across, and then it comes up the Haversian system, and then it goes across the Volkmann canal, and it goes up through another Haversian canal, and it goes across, and eventually it gets into the spongy bone. So basically think of the Volkmann canal as kind of connecting all of bone together, all the osteons and compact bone, all the different parts of your spongy bone together. Okay, and these are three more terms that we've already discussed. All right, so these are just some pictures of compact bone. Spongy bone. Spongy bone is the one we really haven't talked about. Basically, it's made up of a bunch of what we call rods, plates, and spines. And we call those things together, we call them trabeculae. So trabeculae is going to be the bone part of spongy bone, and then it's got all these little spaces in between them. And that's where the red bone marrow is. It occupies the spaces within that trabeculae. And that's where we're going to make our red blood cells, our white blood cells, and our platelets. So last thing we're going to talk about is the two different kinds of bone marrow. Okay, red bone marrow is predominantly found in spongy bone. It's responsible for making all the ones I just mentioned, your erythrocytes, your thrombocytes, your leukocytes. In children, red bone marrow is also found in the medullary cavity because children are growing so quickly, they need to be adding blood a lot faster. Therefore, we need more places to have it. So in children, the diaphysis of the long bones in that medullary cavity will actually still continue to make blood. By the time you before you even hit puberty, probably maybe early adolescence, that's when it stops and the yellow bone marrow starts to invade. So yellow bone marrow is in the medullary cavity of long bones. Your flat bones, your short bones, your regular bones, your sesamoid do not have the medullary cavity, so they will not have this yellow bone marrow. It's predominantly made up of adipose tissue, which you guys know is fat. So basically, that's the main job of it. Now, what can happen over time, it also provides a little bit of strength to the bone as well. Having that fat inside of there, it prevents the bone from actually snapping. It takes a lot of pressure to actually break one of your long bones. In older people, though, you know how their bones become a little bit more brittle, and part of that is because the yellow marrow is no longer just adipose tissue. It actually becomes more of a gelatinous mess, which doesn't really provide much strength. So that's why older people, one of the reasons why older people's bones become a little bit more brittle. Okay, next time we will talk about how bones grow and how bone is replaced and repaired and osteoporosis.